exploring trigonometric formulas, derivation, and real-world application. Hello there! I am Jerry's L. Supirabli, BS Ed Mathematics 1B, and welcome to my video tutorial. Mathematics has always been a source of fascination and joy for me, and I find great satisfaction in exploring its complexities and solving challenging problems. I am constantly seeking to deepen my understanding of mathematical concepts and theories, and I am always eager to engage in discussions and collaborations with others who share my passion for this beautiful and elegant subject. In this video, we're going to discuss the Pythagorean identities, in which are probably the most important trigonometric identities. So let's start with the unit circle. And we have the y coordinates and x coordinates. And we have an angle theta. And to derive these identities, we're going to draw a triangle form that points. And notice that the lengths of the two sides are the absolute value of sine theta and the absolute value of the cosine theta. And a point formed by that angle, cosine theta and sine theta. And the length of the hypotenuse of this right triangle is gonna be 1, because this is a unit circle. Since we are going to derive Pythagorean identities, so that we can use Pythagorean formula to substitute each value, we can use a squared plus b squared is equals to c squared. Again, we use Pythagorean formula. For substitution, we can substitute the a squared into the absolute value of sine theta squared plus the absolute value of cosine theta squared and c squared into 1 squared. Or it can be written as sine squared theta plus cosine squared theta is equals to 1. Therefore, we have the first Pythagorean identities. Through this identity, we can derive two other identities. So, we use sine squared theta plus cosine squared theta is equals to 1. We divided both sides by cosine squared theta, so that sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta is equals to 1. Remember that the quotient identity of sine squared theta over cosine squared theta is equals to tangent squared theta. Then the reciprocal identity of 1 over cosine squared theta is equals to secant squared theta. Therefore, we have secant identity. To derive the third identity, we can still use the first Pythagorean identity. So we can both divide each side by sine squared theta, and sine squared theta over sine squared theta is equals to 1 plus cosine squared theta over sine squared theta, and the left side is 1 over sine squared theta. And remember that the quotient identity of cosine squared theta over sine squared theta is a cotangent squared theta, and the reciprocal identity of 1 over sine squared theta is equals to cosecant squared theta. Pythagorean identities, which is 1 plus cotangent squared theta is equals to cosecant squared theta.
And now, we are going to use our fundamental trigonometric identities. So, let us apply in it in proving trigonometric identities. So, we have the first example. So, our first example is 1 is equals to tangent theta plus cotangent theta all over secant theta cosecant theta. So now we are going to see where is the most complicated in this equation. So this is the most complicated. So copy 1 and we always remember that the quotient identity of tangent theta is sine theta over cosine theta plus the quotient identity of cotangent theta is equals to cosine theta over sine theta. And in the denominator, which is secant theta cosecant theta. So we use also the reciprocal identities. So the reciprocal identities of secant theta is equals to 1 over cosine theta times the reciprocal identities of cosecant theta, which is 1 over sine theta. So fraction form. So if we have fraction form, we need to find the LCD, which is the least common denominator. So we first simplify the numerator. So copy the 1. 1 is equals to the LCD of the denominator, which is cosine theta sine theta. So cosine theta sine theta divided by cosine theta, we have sine theta times the numerator of sine theta is equals to sine squared theta. Sine squared theta plus cosine theta sine theta divided by sine theta, we have cosine theta, and times to the numerator of cosine theta, we have cosine squared theta all over 1 times 1 is equals to 1, and cosine theta times sine theta is equals to cosine theta sine theta. So there must be here. So next, so we always remember that this form is the Pythagorean identity. So nakita natin yung unang Pythagorean identities natin, yung pinakita ko sa inyo. So, sine squared theta plus cosine squared theta. So, equals to 1 over copy cosine, copy the denominator, cosine theta, sine theta. Cosine theta, sine theta. Over 1 over cosine theta, sine theta. And to solve this form, we need to use the reciprocal of this denominator. So it must be 1 is equals to 1 over cosine theta, sine theta times the reciprocal of this, which is cosine theta, sine theta over 1. So we cancel out the cosine, the sine. So we left 1 over 1. 1 over 1 or 1. So 1 is equals to 1. So check. So we proved that 1 is equals to tangent theta plus cotangent theta all over secant theta cosecant theta is equals to 1. So therefore, na-prove natin.
Trigonometry is used in a wide range of fields such as game development, electrical engineering, satellite navigation, and oceanography. In conclusion, trigonometry is a significant field in mathematics that focuses on exploring the connection between the angles and the sides of a right-angled triangle.
If you enjoyed my video tutorial, don't forget to like and share. Thank you for watching. Bye-bye!